Okay, look at number 34. We are doing some more review for your final, and we have a lot to go through, so I got to go fast. Number 34, it says sine, actually no. Yeah, I'm sorry, sine of, I thought it was going to be inverse sine. It's inverse tan. Some of you guys are yapping and you need to stop. Don't make me come over there. Okay, so in this problem, my first thought is go to the inside, right? Got to start on the inside. Once you're on the inside, I got to think about how these can be rewritten. Do you remember that this means I want an angle? So I want tangent of some angle is equal to x over 1. That's a rewrite of this. If you can't do that, you need to learn that, because for inverses, rewriting is like the main thing. Now I know I need to find an angle to answer this question. All right, so I need to find tangent of some angle is x over 1. Well, I got to make a little picture, and I have to imagine, I don't know how long the sides are, but I know the tangent of this angle, tangent means opposite over adjacent. The opposite side's x, the adjacent side is 1. Do you remember how to find the other side? It's always a square root. Does this ring a bell? Square root of, and there's an x and there's a 1 involved. Come on, you can do this. 1 squared plus x squared. Very good. And 1 squared is, of course, just 1. So that side, why do I need that side? Because they're going to ask me to find something like sine, cosine, or tangent. And I'll need all three sides to be able to do that. So, hey, I've got my triangle drawn. How many times have I said this? Once the triangle's done, the rest of it's easy. All it is sine of this picture. Sine of the angle. The only one angle we could use is the central angle, that one. So what's the sine of that? Sine is opposite over hypotenuse, right? So final answer is the sine of this angle, opposite over hypotenuse, x over square root of x squared plus 1, or you could say 1 plus x squared, either way. All right, so this involved two things that were tricky. One was knowing that these sides were actually telling you x and 1 are two of the sides, and then finding the third one. And then the other thing was to just understand you did not have to find the angle. You needed to find sine of that angle. And therefore, you really just needed to know what the sides of the triangle were. So once you've got a nicely labeled triangle, you're pretty much done. All right, that's like 34. 35 is, it's nasty just because it looks so different than all the other ones you've done. Tangent of theta is negative 5.32. Try not two, not t. What on earth does that mean? Have they told me the angle, or have they told me the side ratio? They told me the sides. Because, see, this is where the angle goes. So I'm going to put this over 1. Now they've told me two sides. And now since tangent's negative, I know where to go. All students take calc. Not here and not here. Where's tangent negative? In those two spots that are open. And I'm going to take one of those two spots, like right here, and say tangent of that angle. Tangent's opposite over adjacent. I have to know that this is the opposite and this is the adjacent. So the opposite side's negative 5.32. Something's going wrong here. Other one down here? All right. Okay, hold on. Okay. It wants, oh, it's a trick question because I could, okay, actually I can finish. I'm not doing anything wrong yet. Let me just finish this, what I was thinking. So tangent's opposite over adjacent. Opposite side from this angle right here is negative 5.32. Now that makes sense that it's negative. And then the adjacent side is 1. And then, do I really need to find the third side, though? No, because the question asks for cotangent. What's cotangent compared to tangent? It's just a flip. Okay? Cotangent compared to tangents, just flip it. So the cotangent of this angle is, instead of opposite over adjacent, it's adjacent over opposite. So it's that over that. And could I have done it faster without my picture? Absolutely. But let me warn you, you'll use pictures 9 times for every 1 time that's like this, where you really didn't need the picture. Okay, let's go on to rewriting as logs. You know what just happened? We got done with trig. because now we're in logs. Okay. Oh, there's more trig coming. Boo! Okay, fine. There's at least a big section of not trig. All right, number 36. Did somebody have a question first, though? All right, so let's go to 36. 36 is just a rewrite. Show me that you can rewrite that. It's got all numbers, which sometimes freaks people out. If you really feel bad, you can make one of them into an X or something and then rewrite it that way, but it's just a rewrite. So what do I mean by rewrite? Life has to have a log in it. It doesn't have a log right now. It says 5 to the third equals 125. With a log, you'd have to say log base what? 5 of what? 125 equals what? Good. And a lot of people don't know how to say this. If I were going to say this correctly, I have to say the word base before I hit this, and I have to say the word of before I hit this. Log base 5 of 125 equals 3. Okay. And if you actually put this into a calculator, it would be 3. If you did this 125 and rewrote it as 5 to the third, you'd see it even easier that it would be 3, right? Okay. So that's a rewrite, and hopefully you know how to do those. There's several rewrites in a row there. Let's go to 39. Pi over 10. If I had to change that to degrees, do you think it'd be smarter to use 180 over pi? Or do you think it would have been smarter to use pi over 180? It's pretty obvious which one of these is going to work out nicely. The first one, because this will cancel this, and it's just 180 divided by 10. If nothing's canceling, then you're not doing your conversion right, because you're not going to have pi squared in your answer if you're trying to get degrees or trying to get radians. Okay, so just remember 180 over pi or pi over 180. That's an easy section. Convert to radians, same deal, 180 over pi or pi over 180. Coterminal. I was surprised. I was having several questions about this from people. And 510 degrees, what's coterminal to that? Coterminal means what's in the same place as 510. Well, let's figure out where the heck 510 is. 360 goes to here, right? And then I got to keep going until I hit 510. 360 plus another 90 would make 450. I'm getting close. And 450 plus how much more? 60 more. Just right there. And how much is left in this little angle right there would be like a 30. That's like a reference angle of 30. Okay, but 30 is not the right answer. What they wanted was what's coterminal. What's in the same exact spot as this right here? Well, how can I get there? I can go this way, and I'd be 90 plus 60 more would make what? 150 is coterminal then? 150 is one of your answers? I could go all the way around past it, like this, go past it and then come back to it. That's 360 plus the 150. And the reason, oh, okay, that one doesn't help. All right, I could go backwards to get there. How about that? There's a negative way to get there. Get where I'm going with that? Negative 180 plus another 30 makes negative 210. What's another positive? I can make up an infinite number of this. You know this, right? There's an infinite number of answers. I mean, I can have it go, okay, let's go past it once, then past it again. How about we go past it again? I mean, you can just add 360 a bunch of times, and then 150 more than that. So anyway, I think you get the idea how to find coterminal things. That'll also be some of your easiest points on the test. That's why it's good to go over something like this, because something like that might sound hard, but it's actually super easy. Some easy points for your test. Okay, let's look at the 40. Let me see if we have time to do. I think for 42, I'm going to label the reference angle. Just reference angles. That should be easy for you. Just a reminder: if I have an angle that's like right here, the reference angle for it is the one that's the little one right here. The actual angle's here. The reference angle is like the small triangle angle, the one that you can make for that bigger angle. All right, I think you can handle 42. 43, simplifying using identities. This is getting into some of the tougher trig that we did, where you had to know a big list of identities. Do you want a list? No, that's just the one they give you on the front. That's just a list of the ones that are given to you for free. I'm pretty sure they're not all on there. Nope, those are just the... Wait a minute, some of them are... Let me think now. Interesting. That's not all of them, but that's a lot of them. On the front of your packet, you have a lot of the identities pre-written. Why don't I give you some that are not on there that are important? Sine squared plus cosine squared, this is of theta, equals 1. That's probably the big one. That's the very first one we started with because it's based on a squared plus b squared equals c squared. All right. I don't know that you get all the stuff on the front. That's confusing me because we never gave you all of those. We gave you the ones in the lower right-hand corner. Those were given before. But I don't think it's not my decision. There's 4 of us that teach this class, so I can't just say, I have decided we're going to give you all of those. Yeah, and then I'd have to go back and say, sorry, I was giving you stuff I can't give you. So anyway, I'll find that out for you like before this hour ends. But let's keep moving on. Simplify using identities, 43A. On our list, we have so many of them already given to us, and we already talked about some of them, like sine is equal to 1 over cosecant. Please don't talk right now, some of you. Like those, I shouldn't have to give you a list of those again, I hope, all of the ones that are inverses of each other. I think I even gave you that list earlier on, didn't I? All right, then I'll give you this list right now. Cosine is 1 over secant. Tangent, 1 over cotangent. And then, of course, all of those that are like cosecant, I could start over again and say cosecant is 1 over sine, but I think that'd be kind of repetitious, so I'll stop there. Question? I know how to do all of them, but I want to start with 43A. So, 43A says tangent, cosine. And do you remember one of the strategies was make them all into sines and cosines? That's one of the best strategies you can do, is make everything into sine and cosine, and then a lot of things end up canceling. Okay, that's I'm not doing anything posture. Grab your pencil. Yeah, but you can't write with your arms crossed. Okay, so this tangent is something. This cosine is something. Write down what they both are in sines and cosines. And then things will cancel. And then hopefully you'll know what the answer is. This is like baby, easy ones. This is like R2, like R1.5s. There'll be R2s. There are R2s on the test, and therefore there might be some this easy, yes. Tangent, is that sine over cosine or cosine over sine? I'll give you a hint. Tangent's y over x, and now you should know which one's y. Sine y. Yes, so sine over cosine. Sine, cosine. We always say the sine one. Anyway, the cosine one is cosine over 1. And that way, cancel, cancel, the answer is just sine. If that one gives you trouble, you've got some serious pain coming. Because there's a lot harder ones than that. All right, so I was asked about D as in donkey. I'll help you with that one. Secant y, sine of, I know right away what I'd do. I see this big sine of pi over 2 minus y. Do you recognize that one? That's one of those co-function deals. I'll remind you about those. For instance, here's the co-function one that's right on your list. Sine of pi over 2 minus theta is equal to the co-function. What's a partner of this one? The co-partner. Cosine of what? Theta. Because this and this have a difference of, or they would add up to 90. Remember those? So this is like 90 minus this one. So if this one was, let's say, 40, then this would be 90 minus 40, which is 50. Remember how those go together? Okay. If nothing else, you need to study that list. of these. So I know now that I would transport this out of my equation and put in instead cosine of what? Cosine of y. So I'm going to rewrite this. It's secant of y times cosine of y. Do you get? Because that and that are equal to each other? Because it's one of the cofunction identities? There was a hand up and now it's gone. Yes? There is a list of, let me double check and see if that list is on there. If you look close, you'll see that, okay, it says cosine of the one is equal to sine of the other. It also goes backwards. I'll explain what I'm talking about with a different slide here. Let's say I was talking about tangent of something. Then all I have to do is know, oh, then the cofunction ones are, instead of tangent, you use cotangent. And then it's not just going to be theta. It's going to be that complicated one where you go 90 minus theta, except we don't use 90. It's what? Okay, some of you are screwing around in the back. Stop it. Pi over 2 minus theta. I'm still waiting. Thank you. Stay with me. All right. These two go together. Those are called cofunctions. All right. So you got a ton of those because you can make up any function. Pick any function you want. I'm going to go with, let's say, secant of theta. I can figure out what goes with secant. Cosecant. And then I can say cosecant of the other one, which instead of theta, I can use pi over 2 minus theta. All right. So anyway, those are the cofunction ones. Back to this slide. I had gotten it where I had got into this green one right here. And now how do I finish? Make everything into sines and cosines is a generally helpful thing. So I'm going to take this secant y, change it into 1 over what? 1 over cosine y. That way I got it in sines and cosines. It's all in this case, cosines. And if I cancel those two out, I'm just going to have 1. And that's the answer. 1. All right. So there's a lot in here, but let's do one that has squared in it. Look at number E, or letter E. Look at letter E. Are you doing these with me? Okay, because you can't with your hands on your head. You need pencils. All right, so E. I'd like you to do, you've already finished it? Seriously?
Yes, you did.
All right, cool. Then check and make sure you're doing them right. E is 1 minus sine squared, and I hope you can recognize anytime you see sine squared, there's an app for that. There's a saying for that. There's a identity for that one. What is 1 minus sine squared? Well, the only thing that has sine squared in it is sine squared plus cosine squared equals 1. So if I want to have 1 minus sine squared, that's what I want. I want to put this sine squared over to the other side like this, and then I'll have 1 minus sine squared. And now I've rewritten my identity so that it's the way I want. I want 1 minus sine squared. Oh, well, that's cosine squared. Needs a theta, but okay. So then I have cosine theta. Oh, look at that. Cosine squared theta over cosine theta. And hopefully you remember that those can cancel. It's sort of like saying x squared over x. Final answer would be what? Cosine. Good. All right. Enough of those. Let's flip to the next kind. Excuse me. There's a big honking section of those. So this is the one exception to you should do a couple in each section. On this section, you got to do at least 4 or 5, maybe 6 of those. You don't have to do all of them, but do more than just 2 because that section goes A through P, and that's a pretty big part of the alphabet. Okay, moving on to number 44, sine of 15. That is hard because you're not allowed to use a calculator for that part. So how would you be able to do this? Even if you could use your calculator for that part, sine of 15, you type it in, you get this decimal. The answers for these always look like 1 over square root of 2 plus root 3 over 7. I mean, that's why we're gonna prevent you from just. Actually, I don't think your final doesn't have a calculator allowed, so that'll keep it simple. You won't be using a calculator for this. So how do you do it? You make it into a sum or a difference. This is sine of two numbers that are going to be either added or subtracted. Now think about this. If the number's small, like 15, do you get, I'm going to have to take a big number and subtract something from it? Because if I'm trying to take two small numbers added, I'd have to like do sine of 5 and sine of 10. It would be true, but it's really hard to do because you don't know sine of 5 and you don't know sine of 10. So you have to choose wisely, and I'm going to choose 45 minus 30. Now you can't disagree with this, right? 45 minus 30 is 15. So all I've done is rewritten it like that. But there's a little formula that helps you to know these. This is one of the ones that we would give you on the test because it's not one we expect you to memorize. So if you refer to the front of your packet, you'll see it in there. It says, looking for it. There they are. Sine of alpha plus minus beta. I'm going to write it out. Alpha plus minus beta. And does plus minus matter compared to minus plus? Yes, it does. Sine of alpha plus minus beta equals sine of the alpha cosine of the beta. And is it plus or minus? Well, is it plus minus or minus plus? It's the same. It's plus minus. That means whatever sign you went into this with, you keep that same sign. Sine, cosine, cosine, sine. Cosine alpha, sine beta. All right, so that formula is given to me. I'm not going to have it memorized. So how do I use it? That's alpha. That's beta. So I go sine, cosine, minus, because I use the same sign as was there, cosine, sine. And then I just go through, after I did sine, cosine, cosine, sine, then I go through and write in the numbers. And it's going to be 45, 30, 30, and then 45, 30. Sine, cosine, cosine, sine. All right, and those are ones you should be able to do without a calculator in your head. And that's just one of those things people forget, is that you've learned some pretty powerful math. Sine 45, you can do that in your head now. What's the sine of 45 degrees? Well, you have to make a triangle for it. 1 root 2. Here's 45. What's the sine of that? Sine's opposite over hypotenuse, which means I pick either 45, that one or that one. They're going to give the same answer. Opposite over hypotenuse. That over that, 1 over the square root of 2. So since sine of 45 is 1 over the square root of 2, I'm going to go to the other page and go 1 over square root of 2. And then I'll have to do cosine of 30. Anybody have it memorized? Sine of 30 is 1/2. Yeah, you're right. Sine of 30 is 1/2. I'll put that one in there. And then the last one's cosine of 45. I'll go back to that picture I just made. Cosine of 45. Cosine would be adjacent over hypotenuse, 1 over square root of 2. It's all right. We all make mistakes. The minus is right there. There we go. That looks really messy. Can I put it together? Yeah, because it has a common, what? Common denominator. 2 root 2 here, 2 root 2 here is common denominator. So I can say 1 times root 3 is root 3 minus 1 times 1 is 1. All over the common denominator, 2 root 2. And there's my final answer. Okay, that's called the sum or difference of squares. Familiarize yourself with that front page area there, the plus minus beta thing. If they ask you for a tangent one, you got to use the tangent one. If we ask you for cosine, you use the cosine one. Okay, enough of that. Let's move on to, by the way, the ones that are in like tangent of 5 pi over 12, it's pretty awesome that you're able to actually do this. I mean, just think about that. Coming into this year, if I'd asked you to find tangent of 5 pi over 12, you'd be like, what? And of course, some of you are still like that. But if you think about it, we can change 5 pi over 12 into some number of degrees, couldn't we? And then it'd be like finding tangent of, maybe it's something simple, like maybe it's something like 60 degrees or whatever. All right, so let's try to figure out what that is in degrees. So 5 pi over 12, if I multiply by 180 over pi, which you know how to do, that cancels. And then I can go, 2 goes in here 6 times, 2 goes in there 90 times. And then, let's see, what goes into both of those? 3 goes in here twice, 3 goes in here 30, 30. And then 2 goes in here once, 2 goes in here 15. 15 times 5, 75. So they're really asking you tangent of 75 degrees. Again, you might be like, but I don't know tangent of 75 degrees. But you can change that into tangent of something you do know. 30 plus 45, I like it. And that will add up to 75. And then I have to use the tangent formula from there. All right, I was doing letter C, which is on the top of that next page. All right, verify the following identities. Basically, that means if you're going to verify something, you got to multiply out. It's sort of like proving. You multiply out the one side until it makes into the other side. Cosine of 2x, that's one of those things we give you. Look on the sheet. Cosine 2 theta. There's 1, 2, 3. 3 things you can put in for cosine of 2 theta. You pick one of those and put it in, and it'll pretty quickly get you to 1 minus tangent squared over 1 plus tangent squared. All right, number 46, write that expression as the sine, cosine, or tangent of an angle. Well, the point is, it's got sine and cosine and sine.
No,
Sine, cosine. You're right, but do you get the pattern, sine, cosine, and then sine, cosine is the same exact thing as cosine, sine, right? We can flip them. It's a multiply. So do you get that pattern? Have you seen sine, cosine, sine? No, sine, cosine, cosine, sine before? I have. It's in that one that we give you on the sheet. And that must be the sine of something. Is it plus or minus in this one? We're doing 46a, right? And 46a is a plus in there. So there's a plus in here. So that means this is really one of these. Sine of something plus something. And what are the two somethings? If it's pi over 5 and pi over 2, then those are the two things. So it's sine of, what is alpha and beta? They go here. Alpha and beta. Okay, what's alpha? Pi over 5. What's beta? Pi over 2. And then you'd have a common denominator problem. You can add those together as long as you can figure out a common denominator. I'd make it into tenths, and then you'll have pi over something, and the answer will be in tenths. Change them both to have a common denominator of tenths. I think from there you should be able to handle it. Okay. This bottom one of the page there, number 47, that's another one where we're going to give you the sheet. You got to refer to the sheet. Sine of 2x, it's on the sheet. You don't have that one memorized. Sine of 2x is 2 sine x cosine x. All right. Don't want to do more of that. I'm trying to rush so that we can get done in time. Go to 49. All right. 8 or 9? All right, I'll help with 49. 49a. 49a says, state whether the function is an exponential growth or exponential decay, and then describe its end behavior using limits. This should be an easy one for you. But here's the trick on it. Part A, it looks to me like it's going to be decay because it says f of x equals a decimal to a power. But it's 0.75 to the negative, that's the double twist there, x. Now think about that. This looked like it was decay, right? Because 0.75 is like 75 over 100. Some of you are gotten distracted. Get back to me, please. Everybody, focus. All right, so 75 hundredths here. Do you get that that negative is going to actually make it flip then? And it's going to be 100 over 75 to the x. Now tell me, is it decay or growth? It's growth. See how it looked like decay right at the beginning, but they were trying to fool you because they had a negative up there? Now when you rewrite it like this, when it's truly to the power of x, just to the power of x, then that is bigger than 1, and therefore that's growth. That one's exponential growth. All right, look at B. Oh, okay, sorry. If it's growth, let's make a sketch of it. Once I have a sketch of exponential growth, which you should be able to do too, just that's good enough. Now tell me the end behavior using limits. That's just saying limit of the function as x approaches. All limits start like that. X approaches, and then this is the left or right thing, and then this on the end, that's the height when you get there. That's the y value at the end. Okay, so the limit as x approaches infinity would be way over there. The limit as x approaches infinity is way to the right. If I go way to the right, what's the height when I get there? It's way up there, infinity. So that's your right end limit. Your left end limit is just where x approaches negative infinity. And x approaches negative infinity, I'm going way this way, and it'll be closer and closer and closer to 0. Those are your two limits. Okay, number 50. This is a good one to talk about because, again, I don't feel like this is that hard. This is one of those that you can handle. Do you get when they start with an 800 on top of the little function that means the limit to growth is 800? 800 is the max. 1 plus 90e to the negative 0.2t. Now don't worry, we're not trying to throw you off at that negative in the exponent. That's actually the normal way to do these problems. Because this e is a 2.7, and if they make it negative, it's like flipping it, and that makes it a fraction or a decimal, and that's what we want right there. So that's all normal. It's okay. That is our limit to growth. The highest the population will ever get is 800. Here's the most common screw-up. When they ask, what's the starting value, people think it's 90, because that's where A is. But A is not the starting value. The starting value is where time is 0. So I put a 0 right here, and I figure out, oh, 2 times 0 is 0, e to the 0 is 1, 1 times 90 is 90. Now it's 800 over 1 plus 90. You get what I just did there? I just stuck in the time was 0, because that's the starting value. That's when you start. And then the answer is not 90. It's going to be 800 divided by 1 plus 90. So 800 over 91 is your starting value. To get the starting value, it's like the y-intercept. The y-intercept is where x is 0. You stick a 0 into the function, and that tells you the starting value. All right, when will it be 600? Did they just tell you a time of 600 or a number of people is 600? Number of people, therefore the 600 would go here, and then you would solve it. To get the 600 alone, I would multiply both sides by this, and then I'd have to divide both sides by 600, then I would subtract 1, then I would divide by 90, and I'm getting the clump alone, and in the end I would have like e to the negative 0.2t is equal to some number. Then I would rewrite it as a log. That one's pretty hardcore. All right, I need to keep moving to be able to finish, so I'm going to move on to number 52. 52. It's Exponential growth. Money grows exponentially if it's in an investment that's going up every year. Reality is they don't go up every year. They go up, they go down, they go up, they go down. But on average, you can say they go up. Most stock investments have anyway over the last 50 years. Okay, so you've got this formula. Y equals A, B to the X. Do you know where to put the starting value in one of those? Yep, that's where the start is. And where's the end? The Y, that's the end value. What's the B? The B is some kind of a rate. Okay, so I'm going to look at this problem again now with those eyes and say if it's a problem 52, if it says a $25,000 investment, that goes here, was worth 4921.86. And then the only thing left is to figure out the B, the rate, or the time. Did they tell us the time? I hope they did. They did. 10 years. So I put a 10 right there for the time. Then the B is the only thing I don't know. And you can solve for B. Now, since you won't have a calculator, we would allow this answer to just be divide both sides by 25,000 and then put it to the 1/10 power. Get what I mean? I know you're not going to get the decimal. You're going to have this. That cancels that. And then I have to put to the B power 4921.86 over 25,000 equals B to the 10th. How do we get that 10th off of there? Put it to the power of 1/10. 1/10. B is alone now. There's my answer. Does it ask for an equation? Oh, it says write an equation. Okay. We just found B then. So if we want to write the equation for it, I thought it would just tell what rate. If we want to write the equation, we need Y equals A, B to the X. We know A, 25,000. We now know B. It's that big nasty thing I just wrote. To the power of X. That big nasty thing goes right there. It's all to the power of X. And that says a 1/10 right now, so it would be 1/10 X, or X over 10. Really close. All right. Last one, I think this is probably worth talking about, is number 54. Number 54 in your packet. 54 says, find the logistic function. Okay, I know right away. It looks like this. Limit over 1 plus a b to the x. Everybody write that if you haven't already done number 54. And I got to stick in some things I know. Initial value is 10. Please do not put a 10 right here. That's not right. That does not work for basic logistics. Okay, what do I know? The limit to growth is 40, so I can put the 40 up here. That's true. And now to do this one, I saw that phone underneath your piece of paper. That's not a foot. Oh, okay, fine. I guess you were just being all surreptitious because you were whispering, so I thought you were, okay, fine. Number 54, I'm sorry, I got distracted there. Always trying to catch the cell phone, people. A and B are what I need to figure out. So I need to start with the starting value. The initial value is 10. What do I do with the 10? You got to remember that the starting value is like this 10. That means it's actually giving you two things. It's giving you 0, comma 10. If they give you a start value of 10, they really gave you 0, 10. That means that x is 0 and y is 10. X is 0 and y is 10. Do you get that? That's critical. The starting value is 10, means it's 0, comma 10. At time 0, it's 10. Here's time 0, and here's where I put the 10. So it's 10 equals 40 over 1 plus a, and instead of b to the 0, it disappears because b to the 0 is just 1. So it's just an a. Then I multiply both sides by 1 plus a. 10 times 1 plus a equals 40. Pausing. Okay, I'm finishing this one up, dividing by 10 on both sides. 1 plus a is equal to 4. Subtract 1, a is equal to 3. That's how long it takes you just to find your a value. Watching? Okay, so I just solved for a, and I got a by sticking in that fact about how it started at 10. Again, this is not 10. Instead, I figured out A was 4 after, or 3, sorry. A was 3 after all that. So then I start the problem effectively over again, and I go y equals 40 over 1 plus, and this time I know A. A is 3 times b to the x. Then I have to do it all over again and use the other information they gave me, which was that it was passing through 1 comma 20. If it's going through 1 comma 20, that probably should be further over here, but anyway, 1 comma 20 means that I now have, let's say it's there, right there. So 1 comma 20, I now have an x of 1 and a y of 20. I'm going to put a 1 here and a 20 here, and I solve it. 20 equals 40 over 1 plus 3b to the 1. And b to the 1 is just b, which is nice. Then I'm going to solve by multiplying both sides by the denominator. Remember how to clear fractions. I hope we pounded that into your head enough. Multiply both sides by 1 plus the denominator. 3b equals 40, and the other side it would just cancel, so I'm down to this. Now I'm dividing by 20 on both sides. 1 plus 3b equals 40 divided by 20 is 2. And then I just have to subtract 1, and I have 3b equals 1. b equals 1/3. I'm almost done with the last trig problem. The last pre-calc problem of the year. Y equals 40 over 1 plus, A was 3, right? And then I'm going to put a 3 there then. So 3 times b, which is 1/3 to the x. There it is. Okay. Now you just have to study tonight and take a big old test. That's all I have for today.